Okay, let's talk about the first type of problem for Green's theorem. And the problem will be to evaluate a line integral over the curve C of cosine y dx plus x squared sine of y dy. And C is given by the positively oriented rectangle with these points 0, 0, 2, 0, 2, 1, and 0, 1. And by positive orientation, we of course means that it's going counterclockwise. So if you evaluate this as a line integral, then this will be kind of tedious because you have 4 curves. But with Green's theorem, we can convert the line integral to an area integral. Rather, 4 lines to an area. And so this is a lot more efficient. So remember, let's recall what Green's theorem actually says. It says that f dot dr, the line integral, is equal to an area integral over our region R of qx minus py, where of course p and q are just the components of our vector field. So let's compute qx. So it's x squared sine y, partial derivative in x. So it's 2x sine y, and py will be cosine y, partial derivative in y. So of course we get negative sine y. So our integrand reduces to simply sine of y plus 2x sine of y. And so we can factor out that sine of y. And now our integral is just the integral over the rectangle. So our x goes from 0 to 2, our y goes from 0 to 1, and so we just have sine of y times 1 plus 2x dy dx. We can, of course, factor this. Our x integral is then 1 plus 2x, and our y integral is sine of y. And this is pretty easy, because I think this is just x plus x squared. And then we have minus cosine So let me just go up top. So I think this one is just 2 plus 2 squared times minus cosine 1 plus 1. So we end up just getting, this is 6 times 1 minus cosine 1. That's all there is to it. So the hardest part, of course, is recognizing that you need to use Green's theorem.